This video is for the key features of quadratic functions notes. I tried to start recording this earlier and my calculator decided to go haywire on me, so we're going to try this again and I'll show you what I did to get the information that you already see there on my screen. So what we're going to do is we're going to graph this function 1/2 x squared minus 6, and then we're going to find the key features. So the first thing we did was we created a table. So the easiest way to do that is in y equals, type your equation in, and then we're going to go to second table. And you can pull your information, and that's what I did. You can see here when x is 0, y is -6. So I pulled all these values from this table. There's 2, there's 4. And then I plotted the points. So all of these are each of these points here, okay? And then I connected the line. Okay, so now I'm going to go to the graph of this function. So my first question says, what are the approximate x-intercepts, or zeros? So the zeros are the solutions to this quadratic equation. So if I would use the quadratic formula on this equation, these are the two answers that I would get. They would be the zeros. Now in your calculator, what you can do, you can go to second, trace, and then right here where it says 2, where it says the 0, you can do this, and then we know we're looking for where this line crosses the x-axis. And so we can get an approximate. We know it's in between here and here on the graph, and then we can hit enter. Now, this isn't 100% accurate. So we can also estimate it too. So we know by looking at our graph here, between -3 and -4, and between +3 and +4. So on this one, since it's kind of a wonky number, we're just going to estimate it. The zeros are about -3.5, 0, and 3.5, 0. And that again is where this graph crosses the x-axis. And again, you can do the quadratic formula to find those values as well if you want a more accurate answer. The next one is, what's the y-intercept? So the y-intercept is where the x is 0. So x-intercepts are where the y is 0, where the x is 0. That's our y-intercept. The next one is the vertex. So the vertex is going to be the lowest point or the highest point. So if this was flipped and it was like a frown, we would have a vertex somewhere up here. But in this case, my lowest point here is 0, -6. And then you have to decide, is the vertex a maximum or a minimum point? So when it's a smile, when it's a U, it's going to be the minimum. Your vertex is going to be your lowest point on that graph. And then it says, what is the equation of the axis of symmetry? So the axis of symmetry is where I can cut this in half, or where I can fold it, and this half of the graph, if I fold it over, it lines up nice and neat. And so you can see here how the values match each other going out. So the vertex is the line of your axis of symmetry. And so that line is going to be a vertical line, like this. Okay? Vertical lines start with x equals, and then it's whatever the x value is. The x value is whatever x value you get in your vertex. And then it says name two symmetric points. So again, symmetric points are two different x's with the same y's. Okay? So the two symmetric points we're going to use are -4, 2 and 4, 2. And again, these are like mirror, it's these 2 points here, they're mirror images. So this point is reflected across that line of symmetry over onto quadrant 4 there. All right, on the next one it says graph and determine the key features of the quadratic function f of x equals -x minus 1 squared plus 9. So we're going to do the same thing. We're going to go to y equals. We're going to do -x minus 1 squared plus 9. And then I'm going to go to the table. So second graph brings me up to the table. So when x is -2, y is 0. When x is -1, y is 5. When x is 1, so we're skipping 0. When x is 1, the y is 9. when x is 3. So always watch what values they want, or if you're building your own table. And then when x is 4, y is 0. So then we're going to plot these points. So we've got a point at -2, 0. We've got a point at -1, 5. We've got a point at 1, 9. We've got a point at 3, 5, and a point at 4, 0. And then we can connect the dots here. So this one is going to open downwards. Okay. So it says, what are the x-intercepts? So on this one, it's easy. Wherever the y's are 0, those are our x-intercepts. So our x-intercepts are -2, 0, and 4, 0. And again, in your calculator, you can go to graph, second trace 2, and kind of estimate where those points are. So in between here and here. And we can kind of take a guess somewhere in there, and it tells me here's my 0, -2, 0. And then I can go and I can do the exact same thing over on this side of the graph. All right, it says what is the y-intercept? So I'm going to go back to my table. The y-intercept is where x is 0. So I can pull that information off my table, 0, 8. I can also plug 0 in here and then just type that into my calculator. So to show you what that looks like, I could do negative, and then instead of x, I would do 0 -1 squared plus 9, and it gives me the y value. What is the vertex? So again, that's going to be your highest or lowest point. So here, it's up here, and that point is that 1, 9. So if we go back to the graph, let's see. So you can't find your vertex using that method, but you can use the table. Sometimes you can pick it off the table, sometimes you can't. It says, is the vertex a maximum or a minimum? So when these open like a frown upside down, that is going to be your maximum. And then it says, what is the equation of the axis of the line of symmetry? So these are always going to start with x equals, and you're going to go back to your vertex, whatever the x value is, that's the number you put after x. And then two symmetric points, if we look here, -1, 5 and 3, 5, these 2 points are mirror image from the axis of symmetry. So not across the y-axis, but that axis of symmetry that runs through that graph, it's reflected over that line.